When we think of telescopes, we usually picture instruments that use lenses or mirrors to collect light. These optical telescopes show us planets, stars, and galaxies in breathtaking detail. But the universe doesn't just shine, it also speaks. And to hear it, astronomers invented a new kind of telescope, the radio telescope. Today, let's explore how it was invented, how it works, and how it helps us understand the cosmos in ways that light alone cannot. The invention of radio telescopes. The story begins in 1931 when an engineer named Carl Jansky at Bell Telephone Laboratories was investigating radio static that disrupted communication signals. To track the source, he built a rotating antenna often called Jansky's merry-go-round. After months of study, he discovered something extraordinary. The static wasn't just from thunderstorms but also from the Milky Way galaxy itself. This was the birth of radio astronomy. Soon after, in 1937, Grote Reber, an amateur radio engineer, built the first true parabolic dish radio telescope in his backyard. Unlike Jansky, who stumbled on cosmic radio waves by accident, Reber intentionally mapped the radio sky, confirming that celestial objects emit radio signals just as they emit light. How radio telescopes work. Radio telescopes do not collect visible light. Instead, they capture radio waves, which are a type of electromagnetic radiation with much longer wavelengths than light. Collection. A large parabolic dish acts like a giant mirror, reflecting incoming radio waves to a focal point. Detection. At the focus, a sensitive receiver picks up the faint signals and converts them into electrical currents. Amplification and processing. These signals are amplified and fed into computers, which process the data into maps, graphs, or even images of the radio sky. Because radio waves are weak, radio telescopes often need to be huge, sometimes hundreds of meters across. And when even bigger detail is needed, multiple telescopes can be linked together in interferometry, creating a virtual telescope as large as the distance between them. How we detect objects in space. So what can we detect with them? Radio telescopes reveal objects invisible in ordinary light, pulsars, rapidly spinning neutron stars that emit beams of radio energy, quasars, distant super-bright objects powered by black holes, cold gas clouds where new stars are forming, even though they emit little visible light. Cosmic microwave background, the faint afterglow of the Big Bang itself. By tuning into different radio frequencies, scientists can trace hydrogen gas across galaxies, measure magnetic fields, and even study regions hidden by cosmic dust that optical telescopes cannot see. How radio telescopes complement optical telescopes. Optical telescopes and radio telescopes aren't rivals, they're partners. Optical telescopes show us how objects look in visible light, the colors, shapes, and surface details. Radio telescopes show us how those same objects behave in invisible wavelengths, revealing their structure, energy, and hidden activity. Together, they provide a complete picture of the universe. For example, while an optical telescope may show us the swirling arms of a galaxy, a radio telescope can reveal its hydrogen gas distribution and the supermassive black hole at its core. Conclusion. From Jansky's accidental discovery to today's giant arrays like the Very Large Array in New Mexico and the Square Kilometer Array under construction, radio telescopes have revolutionized astronomy. They let us hear the whispers of the universe, filling in the silence where visible light cannot reach. By combining what we see with optical telescopes and what we hear with radio telescopes, humanity gains a deeper, richer understanding of the cosmos. So the next time you gaze at the night sky, remember, beyond the light of the stars, the universe is also speaking. And thanks to radio telescopes, we can finally listen.